Okay, welcome everybody to the Professional Development Webinar Series for Globe Teachers. And as I said a moment ago, I am going to mute everybody except for Kevin and myself until we have time for questions at the end, and then we'll let everybody at that point raise their hand so that we can, again, make sure that if we do have a number of people on it, that we are making sure we don't have any feedback along the way. So just...
The conference has been muted.
Okay, so I have muted everybody, and I believe Kevin, Kevin, you were area code 734, is that correct?
Yep, that's right.
Oh, okay, so you are not muted, but everybody else is. Right. Great. So I'm just going to do a couple slides before I let Kevin take over and just orient everybody to where we have been and where we're going. So just as a reminder, this is the timeline that we have for all of these webinars. We've already had one on November 5th, which was conducting field investigations, and that one is posted on the Globe website for everyone to see. On November 19th, I did a teacher webinar about the science fairs, answering questions, and also talking about the project evaluation. Today is December 9th, and Kevin is going to talk to us about writing research questions. As a general reminder, next week, December 16th, is going to be one that's done by the GIO on preparing for the Globe International Virtual Science Fair, and it's going to talk about the resources and the rubrics. January 7th, we'll be analyzing data, and I'm writing that one, and we'll get that invitation out to everybody after this. And then January 20th, I'm really excited about this one because it is about writing conclusions using the CER, the Claims, Evidence, and Reasoning Framework. And the person that we have doing it, if anybody's familiar in the education world with Kate McNeil, this is one of her PhD students who's been working a lot with this. So she's going to be doing this webinar for us. So I'm really excited about that. Kate was too busy, but she highly recommended her PhD student. And then on February 11th, we have a Putting It All Together webinar. When we're doing the webinars, we're trying to also make sure you know about the assessment that is affiliated with the science fair projects. So the rubric, we're calling attention to that. And then we're also calling attention to any resources that are already on the Globe website having to do with the different topics. And I'm still looking for teachers that are implementing this in the classroom to write blog posts, and there is a small stipend for it. And I would love to get feedback from teachers about what they have been doing with some of the information and how they're integrating it into their classroom. Then I just want to again acknowledge that NSF has funded these webinars and the regional science fairs that are taking place across the country. And we have the current timeline for those, and those are posted on the website. And these are the geographic areas. And again, this is also on the website, so you can look that up. And then where we've been is, first of all, we have talked about types of investigation questions during the Field Investigations webinar. And Pat Otto from Pacific Education Institute brought up the fact that her guide uses these descriptive, comparative, and correlative questions as the kind of top level characteristics. And she gave us examples of what these different types of questions are. So where that Field Investigations webinar was an overall general picture, these topics now, we're kind of ballooning them around each of these different areas that Pat had talked about. And this first one is about writing research questions. So the comparative questions, and here's some examples of those. Correlation questions and examples of those. And then again, I wanted to bring your attention before I let Kevin take over to the rubrics that are on the International Virtual Science Fair, and also the same rubric that we'll be using for the U.S. Regional Science Fairs. So this is the piece of the rubric that we'll be using to judge those science fair projects. And these are just taken straight from that Intel modified rubric. So here's the one for K through 2, 3 through 5, 6 through 8, and 9 through 12. And I'll make sure that you have the links to all of these, and they're already on the Globe website, and you can download the rubric for the different grade bands. And that's where I'm going to stop and turn the mic and mute myself over and so that Kevin can take over from the University of Toledo. And for those of you that know him, he is one of our superstar scientists for Globe, who does these great surface temperature field campaigns and does a lot of support for teachers locally, and he's going to tell you all about it. So he's had a ton of experience helping teachers to help develop research questions. So Kevin, it's all yours.
Well, thanks, Jen. And well, I already learned something new today with the comparative, descriptive, different types of questions, but I had never categorized them before. So that's cool. I learned something new. Yes, I know many of you know me pretty well. Some of you don't know me, but kind of, I put together some slides to get talking about these research questions, and I was hoping we could have a discussion about it because, my approach, I'm not educated in education after that. And so even the three categories that Jen showed of, I didn't write them down, but the comparative questions, descriptive questions, and I forgot the third one, but I didn't even think of that or know that. So I just do work with teachers and students on developing research questions, and it's, from my experience. So anyway, I guess I'd be a blue-collar education person as opposed to a educated education person. So Jenna, let's look at the slides that we have here. I had some examples. This is somewhat from my normal talk, and then we can talk about questions and maybe specific questions people have. So one of the things I always relate is doing science is like playing soccer. And I became the soccer coach in our town because I had seen a soccer practice. I had never played soccer, but my kids played on a travel team in a different town, so I got to see a decent coach run a practice. So then I became the coach in our own town. Kind of odd, but the idea is when kids learn to play soccer, they don't just learn foot skills and learn how to pass or learn how to shoot. They also play a game, and pretty much every practice we play some kind of scrimmage. And in science, sometimes we teach the kids how to measure things, how to mix chemicals, how to learn the vocabulary, but we never have the kids actually do science. So this is where I relate it to soccer. Basically, we want to learn science by doing science, and even at the kindergarten level, young kids can learn how to do science learn science by doing science. Let's see what we have next, Jen. All right. Well, I actually finished up a pretty big grant on project-based science, and I think it's a good approach. A lot of the things in project-based science are in the next generation science standards. So the idea of having a driving question for your research. And one of the keys that I've been told is that you want the students to design the question. You don't want the teacher to tell the students what their question is. If the students design their own question, they're more invested in it. Now, the challenge, though, is sometimes, like for science fair, for instance, the teachers just let the students do anything. And that's not what I would promote either. I think having a focus on a certain topic and then let the students choose their topic within a certain area of science, I think is the best approach. Of course, then you have the students do investigations, collect data, analyze their data, produce an artifact, so the poster in the case of a science fair. It's really good if you can have the students present somewhere. So, the science fair is one example, but they could present a project to other students at their school or to a government agency. That's really powerful when you have students do a project, maybe it's looking at trees in a city, and then they present their project to the mayor or something like that. And I've had that happen. Have students collaborating on their projects. And what we try to do in Globe, which I don't think we're too successful yet, would be to have collaborations from between schools or even between schools in different countries. And there's a lot of potential there, I think, but untapped right now. And lastly, using technology to do their project. Let's look at the next one. All right, so this is a picture of the American Geophysical Union meeting, which it's going to occur next week this year in San Francisco. And I'm not going this year, but a lot of times I've gone. And this is what the science meetings look like. And a few of you that have gone to these things, you've seen them. Instead of people talking in front of a group, instead of a lecture, there's so many scientists, you have these poster sessions, and then, I don't know how many people, maybe there's 4,000 people at the poster session, maybe there's 500 posters being shown at one time, I don't know, something crazy like that. And I thought, well, we need to do this with students, and this is where I started having a conference of my own. So if you look at the next page, I show, this was actually the first year on the next page, when we had our conference. I think we've had 8 or 10 now, and we call it Satellites, the conference. And we have students gather to display their research projects in Toledo from the local area. And the idea, it's not a science fair. I promoted the conference. So the idea is that the students are sharing their science with other students. Now, at the American Geophysical Union, if you're a student, you also get judged. Scientists will judge your poster, and there can be awards. So I do the same thing with my conference, is have judges, and I try to have the judges incognito. I don't know if you see in this one picture, there's a woman in a black shirt. She's holding like a piece of paper. So, and actually that first year, I was collaborating with people, and they wanted to have actually a thing that says judge on it. These are my collaborators. They had done a lot of the science fairs, and so I was like, okay, that's fine. And then after that, I made it that they don't wear anything that says judge on their shirts. They just walk around with a clipboard. Because the students get nervous when the judge walks up. That's why I don't want there to be judges. If we go to the next one, these are a couple of students from Roswell Kent Middle School. Steve France, he one of the teachers I've worked with for many years, and he's really taken the idea of doing projects to the next level. And what's interesting, he doesn't do it as regular class. He's able to have a special class for globes. These kids, their red shirts have the globe logo on the back, and he basically has this project class that kids sign up for. Now this project the students did, they're trying to look at the temperature of the asphalt and how it affects the bouncing of a ball, which is one of my I don't know, it's sort of close to one of my pet peeves about science fairs. But when you do a science fair and there's 10 kids that look at how high a basketball bounces, and to me it's not terribly creative. Another one that they do a lot, kids do a lot, is how well does popcorn pop. So I want to try to get kids away from these science fair projects that they see online. That's where the parents get it from. They go to a website and that says, here's a good science fair project. But to do Globe as their science fair project, or of course we have our Globe science fairs coming up, and having them do what I consider real science. Let's look at this next one. Now this is from our Sally's conference this past year. Actually what I do is I have the students all the way up through college level, and even PhD students present. So there's college students could be standing next to a second grader, which is an interesting dynamic. Generally the college students are really impressed with the young kids' projects, and then the young kids are not intimidated to go up to the college students' project and look at it and talk to them about it. Let's see, a couple of things on this slide to note. We give out big trophies, just like the sports do, and you have students with happy faces when they get the trophy. The student here on the left, she has won a couple times. She went to Los Angeles last year. She's a student from Detroit, and she looked at water quality in streams. So we can consider that a real project. The last thing, I always have a keynote speaker. Now, last year we had Claudia Alexander, who was the scientist for the Rosetta project, and that was the spaceship that went to the comet, and they landed. It had a probe land on the comet, and unfortunately, she was supposed to talk at the Globe meeting last summer, and unfortunately, she passed away from cancer before the meeting. All right, so the next slide. Just some more projects. These are kids from India when they presented there. And I think it's great when we have kids present at the Globe meetings, because it lets the old people see what the kids can do and their interests. Because sometimes when we just meet as old people, well, we don't know what the kids really want. Let's see, the next slide are some of these kids from Roswell Kent Middle School in Akron. They went to South Africa in 2008, and these are inner city kids. So the project they did was pretty good. They, although their title was not good, they said, "This is why I'm hot." Now the title, I guess, refers to a song at the time, which I have no idea what song it was. I'm like a Billy Joel kind of guy. Anyway, their project was to look at why they didn't have snow days, while their teacher, Mr. France, who lived in the country, he would complain because the school district he lived in would have a snow day, and you'd have to drive from the snowy rural area into the city where there wasn't snow. And they did a study with 6 other schools, and they found out that indeed it was warmer in the cities, urban heat-out effect, and that actually led to less snow in the region, in those areas. So that was a project they were very interested in. The next slide shows some students from Toledo that went to the White House and the teacher, the White House Science Fair. This was the first one in 2010, and they got to present to the president. Next slide is a student from Detroit that I worked with, and she did a water quality project, and you see her behind the president there. And let's see. Okay. I think so. The next picture is just my own kid playing soccer. And like I said, going back to you want the kids to do science, not just practice it. Practice the techniques. So always get them playing. All right. So here's the next thing. Developing a doable question. Now, most questions are too hard for the students to solve. And even when the adults come up with the question, it's too hard. We want the students to pick their own question. Let's look at a couple of these and some more examples on the next slide. All right, so here's another example of a student from Detroit. They do a lot of water quality projects with the teacher there. Let's see. Well, they looked at, is the water coming out of your tap really clean? Another one they've looked at is bottled water, some of the kids there. And, all right. Now this is a simple comparative project. See, I'm learning, right, from what you showed, Jen. So they were looking at different colors of brick and how that affects the temperature of the brick. And it relates to the surface temperature field campaign. So a lot of the teachers I work with, they get their students working on doing the surface temperature field campaign, and then they develop their question related to it. One thing I found, that's just a personal note, when I went to Europe, they have a lot of paving bricks for the roads, and the pavement, when they have those paving bricks, is actually pretty cool. And I think it's because there's basically dirt or sometimes a little vegetation between the bricks. And it's a lot cooler than our asphalt and cement. All right, so the next slide. All right. So this student was looking at the effects of albedo on temperature, and she looked at 3 different cover types. So, these comparative studies are kind of the most basic project a student can do. They can compare 2 different cover types and have a project right off the bat. All right, so next slide. This is a teacher project. When I do my teacher workshops, I had the teachers develop projects right at the workshop. So basically the first 3 days are preparing them to do the project, and then on Thursday they actually do it. So they might collect data before Thursday, but they have to analyze the data, they have to develop a question throughout the first 3 days, plot the results, draw conclusions, and then make a poster board. And I think it's going pretty well to do this in one day. The first year I did it with teachers, I had graduate students help because I thought, oh, well, the graduate students could help them learn about science. But what happened was the graduate students basically kept coming up with these great ideas that would take like a year to solve, and they to do in one day. And I'd walk around the room where they're working, and I'd get the teachers focused on a more doable project, and then I'd go to the next group, and I'd come back around, and they'd have this giant project again when I got around the next time. And so that wasn't good having grad students. They didn't understand that the teachers needed it to be simple. Just they needed to do something, some kind of project. And science people like ourselves, we can help the teachers. I think we can do a good job. So this teacher said, "Can plants save you money?" So she was, of course, adults are interested in saving money, and we looked at putting like a green roof on the building. I don't know how much students are interested in that, but a lot of times students are interested in gardening, that type of thing, so a project on that might be good. All right, next slide. Also, I think focusing on a field campaign is a way to get the students to focus on a project. And I'll show you some of the field campaigns that are going on with Globe or that will be. And they kind of lend themselves to doing a project or to the students asking a question. Let's look at a few of them. The next slide is GPM, Global Precipitation Measurement Mission Program. And basically this is taking rain measurements. These slides were taken from the Globe annual meeting, the science working group that I'm chair of. I presented at the meeting that Henry organized in Los Angeles this past summer. And the person here, Femi, he's from Nigeria, and he's part of this GPM program. So it's actually not hard to take precipitation, rain or snow measurements, and then it can be related to the satellite that's doing the same thing. But even a simple question would be what is the variability or difference in rain between two places, or precipitation between two places? A very simple question to ask. All right, so next one is SMAP, the soil moisture active passive. And Narendra Das is the lead scientist for that. This field campaign is going on right now where students are collecting soil moisture. You just use a can and you dry this. You weigh the can before you take the sample. You weigh the soil sample, and you just take it out of the ground. Then you dry it, weigh it again. The difference in weight becomes the amount of soil moisture, or the moisture. The satellite broke, and I don't know if you guys know the whole story, but having student observations is very helpful then to the scientists. It's kind of a neat way for Globe to interact with the NASA scientists. But again, soil moisture is an interesting topic. I worked with a school, and we were going to look at soil moisture in the schoolyard. So, I was asking the kids, well, what's the question you would want to answer? And they were like, well, we're wondering about our garden because the parents had made a garden in the schoolyard, but all the plants died. We're wondering about the garden. And so I helped them. I said, well, let's just not look at the garden soil moisture. Let's look at other places in the schoolyard. What place do you think will be moist? Which place do you think will be dry? We looked at those and found out that the garden had zero soil moisture. Like, well, how is that possible? Well, the adults had put some vermiculite, almost purely vermiculite, was sort of like styrofoam, thinking that they were making good soil for the garden, but what they did was they made horrible soil. And but the students found that out. This is why the plants died. There's no soil moisture. All right, next one. The surface temperature field campaign is going on right now, and as Jen said, I'm leading it. I developed the protocol for the field campaign for Globe, and anyway, it has research questions built right into it. What's the temperature between grass and asphalt? That leads to urbanization. How is putting up parking lots affecting temperature in buildings, etc.? But other things kids are interested in. A group in the Dominican Republic, they were looking at the temperature of their playground, basketball stars. Anyway, so they put up asphalt basketball courts in all of the schools. Of course, in the Dominican Republic, it's extremely hot in the tropics. So the students looked at different paints they could paint the parking lot. White was too bright, but green cooled the parking lot, or the playground, but it wasn't too reflective, so it wasn't too bright for the kids. So they painted the playgrounds green. So neat application. All right, so next slide is aerosol campaign. Actually mainly done in Europe this past fall, and then next spring they're going to do it again. You need a sun photometer for that. So I won't spend a lot of time on that. I'm guessing not a lot of people have sun photometers, although Todd Ensign in West Virginia, he has a whole bunch, I think. And then the last, oh no, not the last one yet. We have El Nino. Of course, El Nino is pretty strong right now. We really haven't come out in Globe with the guidelines for a El Nino field campaign per se, but El Nino could be a topic that is interesting to students. Basically, how does El Nino affect the weather in their area? So if you look at the next slide, this is the project my son did for Los Angeles. And his class was collaborating with a school in Peru last spring, and they're looking at the temperature. And we just, set up the collaboration between the teachers, because knew the teacher in Peru, and of course it was my son's teacher, so we set up this collaboration. Well, what the kids found out was that in Peru it was really warm, even though it was going into winter, which was our summer. And they said it's from El Nino. And so, I mean, that made a big impact that someone from Peru told, the kids in Michigan that El Nino was affecting their weather. Well, in Michigan right now we have no snow, and it's like 55 degrees. And this is probably the effects of El Nino, our warm December so far. So this is a great project to do with kids so they can learn more about El Nino. Is, how is this year compared to other years, like temperature, precipitation, snowfall, and anyway, great project that kids can do. The next one is the mosquito field campaign. This hasn't come out yet. It will actually, probably in January, the protocol for mosquitoes is going to be released, and then you can have your kids take observations of mosquito larvae. I would guess that for most of us would be sometime in the spring when mosquitoes would come out, and then there's going to be a field campaign associated with that. All right. I think that's where I'm at. So what ideas do you have of projects, and maybe opening it up for some discussion and questions?
So, Kevin, I just want to ask a little bit more about, and we talked about this originally, about these questions that people are asking. So the questions and the examples that you gave, and the idea that the teachers were coming up with questions, and they were ones that were possible to answer within a day.
Right.
Which to me seems like this could be possible in schools. And there's almost this idea that the questions that we have to have need to be ones that are year-long projects. But the message that I'm getting from you is that these can be questions that students can come up with that can be answered in one day, and those are just as valuable as these larger ones, and that it's more the idea of doing the science than it is about this long involved process.
Right. That's my thought. Now, it does take time to show kids how to do the observation, right? So, I'll relate to Timmy's class again. In 4th grade, the teacher was willing to work with me, and I said, well, for the surface temperature field campaign, let's have the kids observe the asphalt and the grass, which they did. They learned how to take observations, but then we said, well, okay, then they developed their own projects. And all the projects were related to the playground, because they loved going on the playground. And they wanted to know, was this playground equipment hotter than that one? And so they were able to do their project in basically one day. But it did take, working with them on how to take observations, did take class time before that. But I was thinking you were asking, like, what observations have kids taken that would be interesting to the scientists. And I'll answer that first. Like the soil moisture one is very interesting right now. I think it's because the scientists, the satellite has broken essentially. And what you can do with the kids is you can get the SMAP soil moisture data from there's a NASA website now. Now I'm drawing a blank on the name. But it has real-time, it's not quite real-time data. And then you can also get surface temperature, the satellite from that same website, and precipitation. So the idea, you could do some of these field campaigns and get satellite imagery, and the kids could see it. And those are pretty much like the soil moisture, precipitation, and surface temperature. I think scientists are using that from GLOBE. Now, I haven't published in quite a while. I have had students do surface temperature CSI, but I haven't gotten any of it published in the journal.
Teachers, these are some of the resources that I'm going to post about the questions and writing research questions. So just before we end, these are also coming in the follow-up email. And so you may want to review them or send them out as links to your teachers. So they are Steps in the Scientific Process, and that's a link. Then we have another webinar on scientist skills and how to develop research a question, and that was in 2012. There's a document, a PDF worksheet that I use all the time with my teachers on what makes a good research question, and that was developed by GIO. And then there is a guide to asking questions that's on the International Virtual Science Fair resource page. And my final word, and Kevin, I'll let you have the final say, but my final word is just to remind you about the webinar next week and to get that word out to your teachers. So I want to say thank you to Kevin, for coming, and all of you here. And I didn't know if there was any final questions in the last minute before Kevin, I'll give you the ability to sign us off. But were there any other final questions?
Okay. And thanks everybody for calling in and for the good questions. And let's make some good globe projects.
Sounds good.
Sounds good.
Thank you.
Thank you.
Thanks, everybody. Bye.
Bye-bye.
Bye.